So this question is quite straightforward. They just tell you that for a GS geometric sequence, the third number is 720 and then the third number is 864. Then we can easily to find out the ratio between them. 720 times R will give you 864. So the ratio is 864 and then divided by the previous term. And we simplify it, we get 6 over 5. After that, we want to get the first term. It's easy. It's because if you have A and then you just jump 2 times, that means times R and times R again. You get 720. So we have another equations. A times R squared will give you 720. Then we just plug it in. So it's equal to 500. Therefore, first term is 500. We finish part A and then we focus on part B. They say that the sum of this term and another term is less than this. That means it gives us an inequality, and then we are going to find the greatest value fulfill this inequality. Pay extra attention, we are talking about the sum of this term only. We are not talking about the sum of first n term, so you don't need to apply the sum formula. We are talking about Tn plus 1, the n plus 1 term, together with 2n plus 1 term is less than 5 times 10 power 14. We are going to solve this inequality. And then for GS, this term is A and then we time out n plus 1 minus 1 times is because of Tn is equal to AR power of n minus 1. Similar reason, this is A R power of 2n plus 1 and then minus back 1 time. So we have A is 500, R power of n, plus A is 500, R power of 2n. We find a common factor 500, so I divide both sides by 500. It do not trigger a change in the direction, it's because 500 is positive. So we have 5 divided by 5 give us 1, and then 10 power 14 minus 20, that means divided by 100, we get 10 power of 12. The ratio of the variable index is 2 to 1 to 0, so this is quadratic inequality. We gather all things on one side in certain order. Then we use our calculator to analyze the range. Because the coefficient here is positive, so we know the function depends on R power of n. It is opening upward. So when we talk about smaller than 0, below certain the ground, we are talking about the middle region is our target. We know that R power of n should between two limits. We use calculator. We find the first root. The smaller root is negative 1,000,000.5, and then the larger root 999,999.5. So we know this one. Don't forget that we already know what is R, and before that, R is a positive value. No matter what is the power, it should be remain positive. So this part is unnecessary. That's why we can simplify it to 0, smaller than R power of n, and then smaller than our larger roots. We can just focus on this part, R power of n, and don't forget we know what is R. R is 6 over 5 from part A. Now from a quadratic inequality become an exponential inequality. We find the power here, so we are going to use some tools to take it out, which is log. Take log on both sides, then n can come out. Then we can divide both sides by log 6 over 5. But you have to check, log 6 over 5, is that positive or not? Because it is positive, so when you divide both sides by this number, it won't trigger a change. It's still smaller than. We get 75.7755 something. So to choose a greatest value of n fulfill this requirement, we can choose 75, we can't choose 76. Therefore, the greatest value of n is 75.